from Kishore, Department of ECE, faculty in Department of ECE, DBSIT, KAVALI. In today's class, I would like to explain about design approach for customized ASICS. So, we have to implement different circuits or design different logic functionality, different designs by using different applications. So those are nothing but, so already we discussed different type of circuits. Those are nothing but full custom ASICs and semi custom ASICs. So whatever the circuit, so we have to follow the design approach for to implement a perfect digital ASICs. So for that one, so we have go for system design. So that system design, it is the process of implementing a desired functionality by using a set of physical components. That means whatever the available components in the market or the industry, so that will be used to implement to develop a desired functionality. So that may be used to VLSI or FPGA circuits. Either it may be used as a VLSI circuits or FPGA. So VLSI is nothing but very large scale integration systems, and FPGA is nothing but field programmable gate arrays. Field programmable gate arrays. So here the VLSI, whatever already we discussed, the stick diagrams and layout diagrams. So how to implement the logic functionality by using the setup, by using a different setup. So here we have to design any application oriented part or a specific logic functionality. We have to follow some methodology. Those are nothing but design specification and the design entry, functional simulation, logic synthesis, gate level simulation, system partitioning, after that floor planning, and the placement and routing, physical verification and testing, fabrication. So here I will tell you how we will follow this procedure. For example, consider, so I have the company, so that means so we have different manufacturing companies, so that is nothing but vendor. So for this company, the customer will be approached to design a specific IC. So that is so we have to differentiate the speed of the IC and the specification, and we have also that will be that the customer describes, so that will be operated the clock speed with 1 megahertz or another speed. So to implement these specifications, so we have to follow the VLSI system design flow. That means the customized ICs, either it may be a semi-custom IC or a full custom IC, whatever the IC. So we have to implement that design. So we have to follow this overall specs. That is nothing but, so whatever the requirements we have, so that will be implemented by using the design specification. So the design specification is nothing but it is a guide. So it will consider or it chooses so what are the specification included within the circuit or within that design. So that design will consider so what type of inputs and what type of outputs, and which type of controlling signals and which type of clock signals. So what where the power limits will be applicable for that circuit. So that overall information will be included within the design specification. So like it is likewise so whenever we have to conduct a seminar or program, so we have to plan before itself we have to do that program with a proper manner. That is nothing but we have to arrange schedule 1, schedule 2, and all our overall program will be considered within a program sheet. So in the same way, whatever the design we are implementing, either it may be off adder or full adder or combinational circuits or sequential circuit, whatever the circuit, that overall information will be consist within the design specification. So why we are going for this VLSI and FPGAs? I will tell one example. So for example, nowadays all of us we are using the mobile phones. For example, consider your mobile phone. There will be a problem with the camera, so that camera is not working in your mobile phone. Then simply you will approach to that mechanic or that electrician. So then simply how to replace that camera into your device. And otherwise, so for example, if a display is a problem, that means if a display is not properly working within our mobile phone, so and simply you will replace another display with your mobile phone. If for example, if the processor will be damaged, then what we will do? So simply we have to go for the specific processor only. So that is the main difference between FPGA circuits and the VLSI. Whatever the specific processor we are having or we are implemented by work of the front-end engineer and the back-end engineer, so that will be implemented within that. The processor will be implemented under VLSI technology, and the remaining circuits, that is whatever the easily replaced from one device or one component to another component, so that type of devices will be implemented under FPGAs, field programmable gate array. So that is the main difference between VLSI and FPGA. So whatever the circuit or whatever the device we are developing, so we have to follow these overall steps, then only we have to fulfill. So after the design specification, so we have to coming to design entry. So that will consist or that will be defined in two ways. So one is the RTL schematic, that is RTL is nothing but resistor transfer level, resistor transfer level, or we can also call the resistor transfer logic. And another one is HDL schematic. So in case of the RTL, whenever we have to design by using the RTL, so it is give a graphical representation, that means a layout representation from the top to bottom level design. So in case of the HDL, so we have to use different languages, that is Verilog, VHDL. By using Verilog and VHDL, so we have to write the code like as a C language or Java. So whatever the design we are implementing, we have to write by following these languages. So we have to enter the entire design specification into a HDL program, that is hardware description language. So that will be done in the design entry. So after the coming to the functional simulation, so a functional simulation verifies the logical functionality of the circuit. It verifies logical function. When, for example, consider a 2-input AND gate. So the logic function for the 2-input AND gate is A into B. 2-input AND gate is A into B. So when we are coming to the simulation part, so we are checking properly whether the implementing logic will be, whatever we are implementing, the logic will be exactly coming or not. So that the output will be exactly specified output, or there will be any delays or any bugs will be coming within the design. So that will be verified under the simulation. And coming to logic synthesis, so it is synthesis will be, it is convert in a simple definition. Synthesis is nothing but it is a converting the software program into the gate level circuit. That is whatever the entire code, this by whatever we defined the logic within the Verilog or HDL. So that entire code will be converted as a circuit. That means as a gate structure. And coming to gate level simulation. So again here the gate level simulation. So it again and again verifies so whether the circuit consists proper inputs and proper outputs and proper logic will be performed with pre-layout simulation. Pre-layout simulation is nothing but, so while we are designing ICs, so that in that ICs, so we are spending more money to implement that circuit. If any bugs or the delays will coming into that ICs, so that will be the entire setup will be waste. So that's why we continuously checking so whether the giving inputs are properly working or the logic will be done within the circuit, and by using that the output will be coming or not, that will be verified by using the gate level and the simulation. And the system partitioning is nothing but, so it will be a larger module will be converted into a small modules. For example, likewise whenever we are constructing a building, so we have to plan a proper space for every module. So there is nothing but system partitioning. That is, so whatever the large module or the large design will be converted into sub-blocks or sub-designs by using system partitioning. So after that dividing, so the floor planning, it estimates, the floor planning is nothing but, it estimates the required chip area within the design. So that means we are having in a design, we are having the inputs and outputs and the resistors, memories. So in what place we are planning, or how much place will be required to each and every individual subsection. So that will be done within the floor plan. So after that, placement and routing. So whenever we name we given the names for the subsection, for example this is 1 and 2, 3, 4. So we have to proper arrangement, that means proper placement and the routing. So we have to make the proper placement for the each and every subsection, and also the interconnections from one device to another device. So that will be performed at the place of placement and routing. So after that we have to do physical verification. So the physical verification, again it will continuously checking whether the circuit is performing proper logic or not. Again, that means the delays and the interconnection delays, the overall concepts will be coming in the physical verification. So finally we have to test again, we have to check the layout and the design rules under the testing procedure. So finally the circuit will be designed. That means finally that whatever the software will be downloaded into the FPGA or CPLD structure. So that will be checked by using the testing, and that the overall information will be given to the back-end engineer. So finally the device will be whatever we are expecting, that means whatever the logic functionality we have to design, whether it may be a combinational or sequential or processor, memory, whatever it will be. So that IC will be came into the picture. That is nothing but fabrication.